Let's talk about 10.6. In 10.6, we are talking about if two chords intersect and to find the different lengths of the two chords on the interior of the circle, then the product of the lengths of the segment is equal to the product of the other lengths of the segments of the other chord. So what that means, if I had a circle here, and we'll say here's a chord, here's a different chord. If this was A and this is B and this is C and this is D, A times B would equal C times D. Okay, so let's try that out. So here we have 4 and x. So 4 times x must equal 2 times 4. We'll multiply them out. So that's 4x equals 8. We divide by 4. X then equals 2. Same process. X and 3, so x times 3. X plus 15, so we put it in the parentheses because that's one term, times 2. We need to distribute this 2 to each term. So this is 3x equals 2x. 1.5 times 2 is 3. I'll just put a times. That simplify this. I'm going to subtract 2x to both sides. This gives me x equals 3. Next one, 12 and x plus 1. So we can say 12 times x plus 1 must equal 10 minus x times 10. Put that in parentheses too. So then 12 gets distributed. So this is 12x plus 12. This 10 distributes. So that is 100 minus 10x. We're going to simplify by adding 10x to both sides. This gives me 22x plus 12 equals 100. Subtract 12. 22x is then 88. If I divide by 22 to both sides, x then is 4. Next, if two secant segments share the same endpoint outside now, no longer inside, but now outside, then the product of the lengths of one secant and its external segment is equal to the product of the other secant and its external segment. So if I had a circle, and we'll call this one segment, and it goes outside, and then we'll say another one, and this goes outside and meets on the inside. And let's label these. Let's call this E, A, B, C, D. We can say E to A, so the red with the red, E to A times the entire thing, EB. So the segment on the outside times the entire thing equals E to C times the entire thing, which is E to D. Let's apply that to what we know, what we have. So here, this is the segment on the outside. So we want to do 3 times the whole thing, which is 3 plus 5, equal the 4 times the whole thing, which is 4 plus x. We're going to simplify. 3 plus 5 is 8. 8 times 3 is 24. I'm going to distribute my 4. So this equals 16 plus 4x. Subtract 16 to both sides. That makes 8x equals 4x. Divide by 4. Divide by 4. X then equals 2. Same thing here. Outside times the whole thing. So 3x times 3x plus x, which is the whole thing, equals 6 times 6 plus 2. I'm going to add the 3x plus x. That makes 4x, so 3x times 4x. 6 plus 2 is 8, so this is 6 times 8. 3 times 4 is 12, x times x is x squared. 6 times 8 is 48. Divide both sides by 12. X squared is then equal to 4. If I square root that, to get rid of the x squared, x is then also 2. This next one, if I do outside, which is 5, the whole thing, which is 5 plus x, must equal outside, which is x, times the whole thing, which is x plus 5. I'm going to distribute, so 25 plus 5x equal x squared plus 5x. If I subtract 5x to both sides, they all go away, so then I'm left with 25 equals x squared. If I square root this, x then is just plain old 5. Okay. Next one is if a secant and a tangent share the same endpoint, the outside, keyword being outside, a circle, then the product of the lengths of the secant and the secant segment and its external segment equals the square of the lengths of the tangent segment. So I'll show you what that means. If I draw a circle, and let's say this is my tangent, and they say this is my secant, because secant cuts through. We'll label this E, A, C, D. We can say E to A square, the tangent is squared, equals EC times the outside times the whole thing times ED. And I'll show you what that means. So here, let's try to find x. So number 7, the tangent squared, so we want 20 squared equals the outside, which is 10, times the whole thing, which is 10 plus x. Simplify this. 20 squared is 400. Distribute my 10. This is 100 plus 10x. I want to subtract 100 to both sides, so this is 300 equals 10x. Divide by 10, divide by 10. X then is equal to just plain old 30. Let's look at number 8. The tangent, which is x, so that's x squared. Now the outside segment, which is 4, times the whole thing, which is 4 plus 5. 4 plus 5 is 9. 9 times 4 is 36, so x squared equals 36. If I square root that, x is then just plain old 6. Next is 10. 10 is the tangent, so 10 squared. Outside segment is 5 times the whole thing, which is 5 plus 3x. Gonna simplify, so 100 equals, distribute, 25 plus 15x. Subtract 25 to both sides. This gives me 75 equals 15x. If I divide by 15 to both sides, x is simply 5.